All right, today we're taking a look at this ISB 6.7. Okay, so you can see our airbox is presently missing, and it's just because it's down on the bench right here. So what we're going to do today, we're going to take a look at something that's a little bit different than most other airboxes, and that's that this airbox here, where our air filter is going to be, has a hard plastic ring, and it does have a lip there, so it does grab. And the other half is a rubber hose, like this guy right here. So this is the right one. But this rubber hose also is a bit stiff. Okay, so it is rubber, it's slightly soft, but this hard plastic elbow that's on here can't seal properly onto our hard plastic airbox. So remember, this is on an ISB 6.7. So what they did in its place is they have this gasket, and it's a little rubber O-ring 0335087 and that little gasket is going to go around the flange of our airbox. All right, so when you get that gasket on there, you want to make sure it's sitting below the lip, and it is there for the air piping to sit on top of, and when the clamp comes down onto it, it's going to seal. So we can push that down till it's past the lip on the airbox. Get it all the way around, same way. Okay, and now when we install this elbow on there, it's going to be a lot snugger, and now it'll have a softer rubber to seal between these two components. So that's really important for us to keep in mind. If you don't find it, so if you've pulled that elbow or you're removing the airbox and you notice that this gasket is missing, so it is not there, you need to look down the system. So you need to look down through and pull the other end that's attached to the turbocharger. And you need to pull that off. Don't worry, that's only light, that's not a hole. Okay, you need to pull the elbow off and actually go and find the gasket, because what happened is you likely, when you pulled this elbow off, you knocked the rubber gasket off of the filter housing and it fell right in. And so then it'll just be sitting down in the bottom of the elbow like this. And when the vehicle starts and air starts to move through, where that rubber gasket will go into the compressor side of the turbocharger, get chopped up, melted up, and if that turbocharger was spinning, when that rubber ends up going in and stopping the compressor wheel, then it stops that shaft very suddenly and it can cook the seals, and you get what we experienced. And this little gasket ends up resulting in needing a new turbocharger or reman turbocharger because the oil seals in the turbocharger failed. All right, so very important you look for this. So if you're removing an airbox like this one, this is that ISB 6.7. If you're removing this airbox, look for this rubber gasket. If it is not there, you need to go and find it. Or if it is going to be sitting in the bottom of this elbow, we are looking at a $4,000 turbocharger, all for this tiny little gasket. Okay, so I gave you the part number for it. Do not simply just buy a new one and replace it, assuming it was just missing, somebody else lost it. Go and look for it. There's only one more connection before the turbocharger, and if you're the one who knocked it off, it is going to be your problem when it gets sucked in there. Keeping in the theme of air systems, let's talk about air system clamps. So almost all of our charge air lines, our aftercooler lines, our high pressure air lines after the turbocharger, all have these constant pressure clamps. Okay, so these constant pressure clamps have a spring or a set of Belleville washers. All right, and they hold this nut that's right here under tension, and they hold the clamp under tension. Because of this band structure, we don't get like a tenting effect. We don't. One of the things that can happen with a worm clamp is when they come together, they create this sort of like point where the worm clamp grabs. These constant pressure clamps do a better job of wrapping around the whole hose, supporting the whole hose and putting constant pressure, that's why they're called that, across the whole hose. and this prevents leaks. We need to make sure that we're torquing these correctly, so you need to torque them enough that they don't come loose, but not so much that you strip these fine threads or gall up this nut, because what will happen is you'll hourglass stretch it, and then due to vibration, it will snap in the spring down the road. When it snaps in the spring down the road, the whole clamp will come loose, and then under boost pressure, the whole airline will come off. And of course, the customer will have a no power complaint. And if they drive it for any length of time, they have a potential of dusting that engine, because while we lose the air pressure on one side, we create suction on the other. And so we need to make sure we're installing these clamps correctly. We also need to make sure we're inspecting them correctly. And that means we're actually checking. You can give them a little tug on the side right here, and you're actually seeing that the whole clamp is tight. Now, there is a specification. I used to use it when I worked at Caterpillar. They had a bulletin on these clamps coming loose as well, because everybody was over torquing them, stretching the threaded section that's inside this spring, and then it would break and the clamp would come loose. And so the clamp that was more expensive than a worm type clamp and supposed to be better was actually failing. Okay, while constant pressure clamps have their own challenges, they are still significantly better than these worm type clamps. These are more likely to strip out from over torque than constant pressures are. And so I'll put the specs on the screen right here, and that will be for us to know what specification is supposed to be used. And keep in mind, it's there to protect this threaded rod from not stretching in the spring. You can't see it in here if you stretch it, if you pull it too tight. Okay, if you over torque them, which is really easy, and most guys use their electric ratchet on here and they just start going until the thing doesn't move anymore. You stretch this, it can snap and break. Now, we need to inspect them to make sure they're actually snug, they're actually tight, and the clamps are actually grabbing. Another thing to look for is that you see this clamp is on the component side of the hump. See how it goes from clamp to this rubber hump right here? That's the rubber, that's the plastic lip or aluminum lip, depending on the housing. And we should make sure that that clamp is put right behind that lip. This one is perfect, just the way it is. All right, if we put it too far back, what can happen is the hose can balloon to the clamp and it can actually get fatigued in that hump and fail. So we just got to be careful that we install these clamps correctly. If you have enough hose to install 2 clamps, those work even better. So on our high pressure, big diameter type hoses, it works really good to have 2 of them. But if you're going to use 2, you want to flip them. So if you were installing the second one, you would actually install it on the other side of the hose with the clamp up, and this one the clamp down. You can do them on opposite sides, clamp in the same direction, but you want to make sure that your clamp is on opposite sides of the hose. All right, so the reason why we're talking about inspections is this is one that the vehicle went down the road after we had done unrelated work on, but we didn't notice when we visually worked on it that this nut clearly is rusted in place. This was exactly how it came off the truck. Either it was backed off because it wasn't torqued properly. That's the most likely occurrence. They are rare to back off when they are torqued correctly. But what we can see here, if we pull that clamp in, is there is significant amounts of rust in here. We are unable to turn this nut on the stem here, and so this guy was rusted in place. What happened is customer ended up driving down the road. In a few minutes we hit boost pressure and the charge air line blew off. Obviously had a low power complaint, and so this would have been caught. If we had done even the wiggle check on this clamp, we would have noticed movement and we would have seen that that clamp had failed, and instead of having it be embarrassing that the customer found it when the line blew off, we would have been able to say, hey, you have a failed charge air line. We need to replace that clamp ahead of time. All right, so really important on our air systems that we seal really well. Keep in mind that on the pressure side, we're holding in the boost that allows our air fuel mixture. And on our suction side, we are preventing unwanted contamination from entering into our air system, which will result in dusting our engine. Keep them tight out there.